So here we're going to talk about a phase, P-H-A-S-E. And a phase, by definition, is any mechanically separable part of a system. So it is, well, let's just write it here in words, a mechanically separable part of a system. Notice that we've introduced this other term here, system. What do we mean by that? Well, a system is any part of the universe that you're interested in. It could be the entire Earth or just the atmosphere or the oceans. It could be a single mineral. It could be an entire rock. The system is whatever you are interested in studying. And so this is something you define based on the kinds of questions you're asking, based on the kinds of things that you want to find out. So now let's get back to a phase. Once we've defined a system, what is a phase? Well, let's say we start with this material here. There's a photograph from the online mineralogy textbook of Dexter Perkins, and it shows an example of perthite. And perthite is a mixture of two kinds of feldspars. This pinkish stuff over here is a potassium-rich feldspar, and the grayish stuff in between is sodium-rich. So we have two kinds of feldspars. And those feldspars can be mechanically separated. You can take a sledgehammer to this rock and bash it up into little pieces, and then put all the little pink pieces into one little pile, and then you could take all the white pieces and then put them into another pile. So you can imagine a pile over here of sodium-rich stuff. And then we would have separated those two phases by mechanical means using our little sledgehammer over here. And that would probably be about all we might be able to find in this sample here. I don't see anything else that's obvious. Here's another photo, also from the online textbook of Dexter Perkins, but it shows a basaltic rock. And there are a couple of different phases. If your system happens to be stuff that came out of a volcano, then we'd be interested in a couple of things. There's this green material here, which is olivine. There's some more over there and there. It's scattered throughout the rock. That's one of the phases. So that stuff over there is the mineral olivine, which is right OL. Then there's this black stuff that forms the matrix, and that stuff looks like it is probably mostly glass. There might be other kinds of minerals. If we were to blow up this area here and magnify it, we might find other phases. For the time being, let's pretend that what we see is all that there is. So we have two phases, olivine and glass. Is there anything else? Well, yes, there is. We have these holes in the rock here that are called vesicles, and they at one time held gas. Well, we currently hold a gas too. The gas that they hold is air, but when this material was, before it was erupted or immediately after it was erupted, those vesicles might have been filled with a combination of water vapor and CO2 that's now left the system. So in this case here, we would have three phases. Over here we had two phases for perthite. We'll use the Greek symbol phi for phase, so we had two phases over here. For a volcanologist interested in this stuff, we'd have three phases. The stuff that filled the vesicles. This has already been mechanically separated because it's less dense than the rest of the rock. It was separated probably shortly after, maybe even a little bit before eruption. And then there's the olivine, and then there's the glass. But there are other phases as well. If you're not a volcanologist, instead, let's say you're interested in superficial processes like weathering, then there's all this white stuff over here. It looks like some kind of calcium carbonate deposit, caliche, so that would be a fourth phase. And we could separate that by scraping it off. It probably exists on the surface. Then we have this reddish stain over here. There might be some microscopic layers of hematite that relate to oxygen that was originally in the olivine, and then it reacted with some of the oxygen either in circulating waters or maybe the atmosphere to give us the mineral hematites. The iron would come from the olivine itself, contributed to the rock, and then the O2 would be from, let's say, water, probably more than likely water, maybe the same waters that deposited this caliche. So we would have additional phases, maybe 5 phases, if we're interested in the surface environment and the kinds of weathering reactions that take place. So then that takes us back to this issue of system. The system is what we are interested in. So just to sum up, the system is that part of the universe that we're interested in, and depending on how you define that system, that'll affect the number of phases that you count. And phases are those parts of the system that we can separate by mechanical means. What we mean by that as a corollary is that we don't need chemical reactions to break apart the materials and separate them out. So we can use simply color or hardness or other kinds of physical properties In this case, the example I gave is we bash stuff up with a hammer and then use that kind of mechanical means. As long as we're using mechanical means rather than dissolving something into an acid or another kind of solution to separate the materials, if we can separate them that way, then we have things that are phases. If we break phases down further, then we have what are called components, and we'll talk about components in a separate video.